In today's class, we picked up where we left off yesterday with lesson 11. What is the same? The first activity says a person's hands are mirror images of each other. In the diagram, a left hand is labeled. It asks you to mark all of the right hands. So go ahead and pause this video and mark all of the right hands. Again, notice that the left hand is labeled. So you might have noticed that there are some hands in this diagram that are shaped the way that a right hand would be shaped, which is opposite how a left hand would be shaped. This one right here, we see looks like a right hand because the thumb is facing in the opposite direction as on the left hand. The same would be true of this hand, and the same would be true of this hand. But what this activity is designed to help you notice is that even though some of the hands look like right hands and others look like left hands, we still know that the shape is ultimately what am I going to say? Yeah, a reflection. Because if I was to flip the right hand onto the left hand or the other way around, flip the left hand onto the right hand, we would end up with the exact same shape. They would be sitting on top of each other. And so we know that even though the left hand and the right hands look different, they could be rigidly transformed to end up as the same shape. So the next activity has A, B, C, D, and E, and it asks you to determine whether or not the pairs of shapes are the same for all 5 of the examples. I want you to go ahead and pause this video and answer questions A, B, C, and D, please. So the question that I really want to talk about is question C, and it's similar to the hands example. You might have noticed that as these shapes are, they're not the same. And what I mean by that is if you dragged the shape on the left on top of the shape on the right, they would not match up. This spiral on the left is different from the spiral on the right, and they couldn't sit on top of each other. But similar to the hands example, if we were to reflect the first spiral over this red dotted line onto the second spiral, the two shapes would then be the same. So the question that we're addressing here is, what does it mean when you can transform a shape with a rigid transformation? So a reflection, a rotation, or a translation. Does that mean that the shape is the same? And does it matter which type of translation or transformation, I should say, does it matter which type of transformation we're conducting? Because when you look at a shape like A, A has two shapes that are exactly the same. We would just need to spin it around, right? If we spin this around, rotate it 180 degrees, A has two identical images. In B, they're obviously not the same because they're a different size. We would have to change the size and the angles of the shape. But in C, we have to flip it. We have to reflect. And those are some of the differences we noticed in A, B, C, D, and E. Now, in the next activity, you are going to see 7 rectangles. And the question asks you, which of the rectangles have the same area as rectangle R, but a different perimeter? And then same perimeter, but different area. And the third question is which one has both the same area and the same perimeter. So I want you to go ahead and answer these 3 questions using the shapes in this image to help you. So you might have noticed that there are shapes that have the same perimeter as R, but do not have the same area. For example, if we look at shape D, we can see that the perimeter or the distance around the shape is 4, 5, 9, 10. Just like in R, they have the same perimeter, but the area is going to be base 4 multiplied by height, which is 1. So the perimeter equals 10 units, but the area equals 4 square units. I'm just writing u squared to show square units. Whereas in R, we know that we have a perimeter of 10 units, but the area would be base times height, which is 2 times 3, and so the area would be 12, or 6, not 12. Not sure where I got 12 from. Oops. Oh, Miss Canez, I cleared everything. Let's see, we were just talking about the perimeter, which would be 10 units squared. And then we have the area, which we know would be base times height, 2 times 3, 6 units squared. And I should note that perimeter is not in units squared, it's just in units. Okay, and D, we already said the perimeter was 10 units because we add all the side lengths, but the area would be 4 times 1, which would be 4 square units. And this was for D. Now, there are other shapes that have the same area, but a different perimeter. Remember, area is base times height. So if I look at a shape like shape B, where my base is 6 and my height is 1, I know that the area of B is 6 units squared, but the perimeter of B is just going to be the distance around the shape, which would be 6, 7, 13, 14 units. And so in shape B, I can see that my perimeter is different from R. The perimeter is 14 instead of 10, but the area is the same. It's 6 units squared. And then we have shapes like shape A, where the side lengths are exactly the same, 2 and 3. And so we know that the perimeter and the area of shape A are going to match shape R exactly because the base and the height are the same. And so it's important to note that we can have shapes that share one quality or one characteristic, like perimeter, and not another measurement, like area. So the question is, use the materials from the geometry toolkit to decide which rectangles are congruent. And it wants you to mark the congruent rectangles with the same color. This word congruent really just means the same. And you can imagine in class when we're using that tracing paper, a congruent rectangle is one that you would be able to place directly on top of the other. We know that congruent rectangles have a few features. They have the same angle measures. All of the angle measures are equal. I'm just writing angle for space reasons, but what this means is all the angle measures are equal. All the side lengths are also equal. And of course, if the side lengths are equal, we know that the perimeter would also be the same. And then finally, the area is also going to be equal. And so go ahead and mark on this task all of the shapes that are congruent. So they need the same angles, the same side lengths, and the same area. Notice that you can use these tools to help you because you could draw a square over R. I should have picked rectangle and not square, but then you could move it to measure it against A. So you would just select rectangle instead of square, but you could draw a rectangle on R, and then you could drag it around to the other shapes, and you can twist, just like you would with a piece of tracing paper, to see whether or not they match up. So answer this question, pause the video if you need to, and come back for the last activity. So the last activity says in square ABCD, points E, F, G, and H are midpoints of their respective sides. So F is halfway between A and D, E is halfway between D and C, and so on. It says what fraction of the square ABCD is shaded? So you're able to investigate this question with the same tools that we used before. So you can draw a square, for example, in the square here. You might also want to split it up into smaller shapes, like maybe a triangle, to investigate this portion here. And you can adjust the way that the triangle is drawn, I believe, by playing with the sides. And your job is to determine what fraction of this entire shape is shaded. Go ahead and tell me your reasoning here. And this is the last activity you need to complete on 8.1.11. You have two other things to take care of to make up for today's classwork. Number one is you need to complete the exit ticket. The exit ticket is located in the main folder for today's class. And then the second thing that you need to complete is the independent practice for today, which is actually located right here in this document. Everyone's doing it in GeoGebra, so the practice right here. If you have any questions about those directions, please don't forget to send me an email.